Good morning, students. Yesterday we have completed total energy of the electron in the orbit. After deriving the expression, the total energy of the electron, that is nth orbital energy minus m z square e fourth 8 epsilon square n square h square, राइट इसके लिए मैं हिंट भी दिया था. व्हाट इज दैट हिंट? माजी आत नाही. सो इसके लिए आप आत नाही बोले तो एन एच ई एन स्क्वायर एच स्क्वायर एप्सिलॉन नॉट स्क्वायर, मैं हिंट के हिसाब से. सो इफ आई कंसिडर दिस इक्वेशन एंड डू द सर्टेन एनालाइजेशन, if I consider hydrogen atom, for hydrogen atom Z equals to 1, then nth orbital energy minus m Z equals to 1 square e fourth divided by 8 n square h square epsilon naught square. This is nothing but minus, I write 1 by n square separate. So m e fourth h square epsilon naught square. Now mass of the electron 9.1 into 10 to the power minus 31 kg, charge of the electron 1.6 into 10 to the power minus 19 coulomb, Planck's constant H 6.625 into 10 to the power minus 34 joule second, epsilon naught 8.854 into 10 to the power minus 14. By substituting all these constant values, we can get nth orbital energy is equals to minus 13.6 divided by n square in electron volt. You know that how to convert electron volt into joule. That is in the first topic, dual nature of the matter. So this is nothing but minus 13.6 divided by n square electron volt. Now this is our equation. By considering hydrogen atom Z equals to 1, by substituting all the constant values, the value of this one is minus 13.6 electron volt, 1 by n square as it is, minus as it is, minus 13.6 divided by n square electron volt. If I want to calculate nth orbital energy in generally for any atom by considering Z, if I take Z equals to 1, that is specifically for hydrogen atom. If I take any element, hydrogen like atoms, then in general for any atom by considering Z, so Enth equals to minus 13.6 divided by En square, Z as it is, that is nothing but यहाँ पे Z square as it is, Z square, it is in electron volts. Right? Now this is about what? In generally for any atom by considering the Z, nth orbital energy minus 13.6 divided by n square into Z square, that is in terms of what? Electron volt. Right? If I want to calculate the individual energy for the hydrogen atom, that is the energy possessed by the electron in the respective orbits, then energy of the first orbit, third one, this is I call first, this is second, third. Let Enth equals to minus 13.6 divided by n square electron volt. If n equals to 1, which implies E1 equals to minus 13.6 divided by 1 square, this is in terms of electron volt, E1 equals to minus 13.6 electron volt. This is first orbital energy. If I take n equals to 2, that is E2 equals to minus 13.6 divided by 2 square electron volt, right? This is minus 3.4 electron volt. If I take n equals to 3, E2 minus 13.6 divided by 3 square, 9 electron volt. So 1.51 electron volt. If I take n equals to 4, n equals to 3, n equals to 4, minus 13.6 divided by 4 square, 16. So minus 0.84 or 85 electron volt. चेक कर सकते हैं. n equals to 5, E5 minus 13.6 divided by 5 square electron volt, 0.51 electron volt. If I take n equals to infinity, then E equals to 0. That energy is called ionization energy. एक बार चेक कर देख लो. So अब कैलकुलेटर है तो आप चेक कर सकते हैं, डिवाइडेड बाय कर सकते हैं हर एक टर्म को, देन यू कैन गेट द आंसर्स फॉर दैट एवरीवन. एक बार चेक कर लो सही आता है क्या नहीं. ये 25 से डिवाइड करें 0.54 आता होगा शायद, चेक कर ले एक बार. 0.54 इलेक्ट्रॉन वोल्ट. My aim is that if I take n equals to infinity, then E infinity is 0. Now this energy is called ionization energy. For hydrogen atom, the requirement of the ionization energy is plus 13.6 electron volt. n equals to infinity, number by infinity is 0. Right? एक बार पूरे equations देख लो. Then I go for one more important derivation, that is equation for wave number. अब चेक कर सकते हैं पूरे. Right? If I take n equals to infinity, infinity equals to 0, that energy is called ionization energy. For hydrogen atom, the ionization energy required is plus 13.6 electron volt. If you supply 13.6 electron volt, we can easily remove the electron from the orbit and it get ionized. Ionization means what? To remove the electron completely from the orbit. Whatever the amount of energy is required, that is called ionization energy. For hydrogen atom, the ionization energy is plus 13.6 electron volt. Now this energy is here generally called ionization energy. Okay? Then, now whatever the equation we have proved yesterday, we have analyzed it. Then I go for wave number, expression for wave number. Then I go for Bohr's frequency condition. Because of that, having the Bohr's frequency condition, we are coming across the expression for wave numbers. Wave number. That is nu bar or 1 by lambda. When we are going to get the wavelength? When there is the existence of the frequency. When the existence of the frequency, when there is the existence of what? Radiation takes place. According to the Bohr in his postulates, the electrons are revolving in a permitted non-radiating orbit. When the electrons jumps from any higher orbit to the lower orbit, then only the energy is emitted. When the energy is emitted, that energy emitted is in the form of radiation. That radiation is in the form of what energy? That is E equals to h nu. So, the wave number is defined as the number of waves contained in 1 meter length of the medium. That measures what? Wave number. The number of waves contained in 1 meter length of the medium is known as wave number. So it is the reciprocal of wavelength. It is noted by nu bar. So when the electron jumps from any higher orbit to the lower orbit, then only the energy is emitted. According to the Bohr's postulate, energy emitted E equals to when the electron jumps from any higher orbit to the lower orbit. I can write the energy emitted from higher orbit to the lower orbit where N2 is greater than N1. Higher orbital state is N2, lower orbital state is N1. When the electron jumps from higher orbit to lower orbit, then only it emits energy E. E equals to h nu. What is En2? We know that energy of the nth orbit माझी आत नाही एप्सिलॉन नॉट n स्क्वायर h स्क्वायर एप्सिलॉन नॉट स्क्वायर झूठ बोल रहे हैं माइनस n2 is replaced by here En2 replace n by n2 En2 that is nothing but higher energy state minus m z square e fourth replace n by n2 n2 square h square epsilon naught square minus already है a minus m z square e fourth 8 n1 replace n by n1 खत्म जब माइनस आता है you have to be take the for your precaution that is nothing but in the bracket डायरेक्टली लिख सकते माइनस ऑफ माइनस प्लस बोल के जब नेगेटिव आता है यू टेक द प्रिकॉशन दैट सो द इक्वेशन शुड नॉट बी रिटन वंस अगेन c इक्वल्स टू न्यू लैम्डा न्यू इक्वल्स टू c बाय लैम्डा yes c बाय लैम्डा माइनस m z स्क्वायर e फोर्थ डिवाइडेड बाय 8 h स्क्वायर एप्सिलॉन नॉट स्क्वायर n2 स्क्वायर दूर लिख दूं मैं माइनस ऑफ माइनस प्लस m z स्क्वायर e फोर्थ 8 h square epsilon naught square n1 square because यहाँ पे यूज करने से क्या है because c equals to nu lambda nu equals to c by lambda जो कुछ भी यूज करे सो वहाँ पे साइड में रखे ए पॉजिटिव फर्स्ट लिख दूँ मैं ए c by lambda is equals to m z square e fourth 8 h square epsilon naught square 1 by n square positive first minus 1 by n2 square सही है right I need 1 by lambda that gives wave number so 1 by lambda is equals to a 1 by hc बाहर ले ले तो मैं नीचे आ जाता a m square m z square e fourth 8 h square epsilon naught square ब्रैकेट में 1 by n1 square minus 1 by n2 square as it is इसको नीट लिख दूँ मैं m z square e fourth 8 epsilon naught square ch cube bracket 1 by n1 square minus 1 by n2 square this 1 by lambda is nothing but wave number m z square e fourth 8 epsilon naught square ch cube 1 by n1 square minus 1 by n2 square right एक बार देख लो पूरे इक्वेशन कुछ भी नहीं है बेसिक इक्वेशन यहाँ पे when the wavelength is going to be obtained when the electron jumps from any higher orbit to the lower orbit the electron jumps from higher orbit second orbit to the first orbit the energy radiated is e2 is nothing but energy of the second orbit energy of the first orbit n2 is greater than n1 so this is our basic equation for n2 replace n by n2 n1 replace n by n1 here पूरे यहाँ पे है देख लो एक बार अच्छी तरह से देखो, mass of the electron is constant, atomic number Z is constant for given element, charge of the electron is constant, epsilon naught is constant, 8 constant, C constant, H constant. C is nothing but velocity of light, velocity of photon भी ले सकते हैं. Here m z square e fourth divided by 8 epsilon naught square ch cube is equals to constant. This is called Rydberg constant. Name of the scientist, Rydberg constant, Rydberg, and the constant is called Rydberg constant. Then finally we can write nu bar is equals to 1 by lambda is equals to r 1 by n1 square minus 1 by n2 square. Now this is the expression for wave numbers. So experimentally it is found that, and theoretically it is also found that both the values are exactly matching for hydrogen atom. So the value of R for hydrogen atom, Z equals to 1. Then R equals to, by substituting all the constant value with hydrogen atom Z equals to 1.097 into 10 to the power of 7. So 1 by lambda, that is nothing but this is per meter. Now this is the value of what? Rydberg constant. So Rydberg constant is calculated for hydrogen atom Z equals to 1 by substituting all the constant values remaining, mass, m, e, epsilon naught, c and h values. Finally we get the value of Rydberg constant 1.097 into 10 to the power of 7. Yes, and it is per meter. Now this is the expression for wave number. What is the wave number? The number of waves contained in 1 meter length of the medium is known as wave number. It is a reciprocal of the wavelength and its SI unit is per meter. According to the Bose postulates, the energy is emitted only when the electrons are permitted, when they jumps from higher orbit to the lower orbit. When the electron jumps from any higher orbit to the lower orbit, we can get the energy radiated E. This E2 is nothing but energy of the second orbit, E1 is nothing but energy of the first orbit, N2 is the higher orbit and N1 is the lower orbit. So we know that nth orbital energy माझे आतना है, that is our concept. झूठ बोल रहे माइनस, याद रखने के लिए for N2 replace N by N2, N1 replace N by N1, minus of minus plus, पूरे constant value बाहर निकालो, I replace nu by C by lambda. Then I need 1 by lambda, that nothing but wave number. A पूरे constant है. Now this constant is nothing but Rydberg constant. The value of the Rydberg constant for hydrogen atom, that is by considering Z equals to 1, by substituting all the constant values, we get 1.097 into 10 to the power of 7 per meter. Now this is the expression for wave number. Is it clear? Expression for wave number, simply I have written here wave number. Is it clear? Yes. मेरे hint काम को आ गए? पूरे hint मालूम हो गए? Nth orbital radius, nth orbital energy, right? Is it clear? अगर आपको समझ में आ गया, let me go for next spectral series. नाम के वास्ते इक्वेशन है, कुछ काम के नहीं है, पूरे देखते हैं आप लोगों को डर लगता कुछ नहीं. हिंट दिए सो nth orbital energy, माजी आत नहीं, झूठ बोल रहे माइनस साइन, माजी एम जेड स्क्वायर फोर आत नहीं NHE सबको स्क्वायर, झूठ बोल रहे माइनस, कुछ भी नहीं. खाली इक्वेशन देखते आदमी डर जाता, कुछ भी नहीं है. ये मुरमुरे के थैले रहते ना घर में, क्या थैले लगाए जी, मुरमुरे के थैले, घर भर पूरे थैले लगाए, बहुत अमीर है लगते हैं लोग, कौन तो जाके ऐसा धक्का दे दिया पूरे थैले गिर जाते. वैसे हो मुरमुरे के थैले जैसा हो, उसके अंदर कोई दम ही नहीं है, नाम के वास्ते दिखावे के लिए है वो. डर जाता आदमी, देखते हैं कैसा लिखना बोल के, कुछ नहीं, हिंट दिए सो उसके हिसाब से आराम से जाओ. Shall I go for the next? Yes, I go for spectral series. निकाल देता हूँ स्पेक्ट्रल सीरीज. इससे पहले हम पढ़े सो है लाइन एमिशन स्पेक्ट्रम, line absorption spectrum. Then we go for detail here, spectral series. By conducting the experiment by Niels Bohr by using the hydrogen atom. So, spectral series. When we get the spectra, when the gas or vapor is heated at low pressure, it emits the radiation. That emitted radiation consisting of what? Certain lines which have got the particular wavelengths. Then we can say that we can get spectra. So, the spectral series is obtained when you take the hydrogen gas and it is heated. Then the electrons are get excited by receiving the thermal energy. When they are get excited, they goes to the different energy state depending upon how much amount of the heat energy is received by them. After staying certain interval of the time in the higher energy state, they must come to their original state, lower state. When they jumps from higher energy state to the lower energy state, excited states to the lower state, they emits the radiation. When they emits the radiation, then the radiation consists of particular wavelengths, and that series is known as spectral series. We get the spectra, that spectra consisting of particular wavelengths, hence we can say that spectral series. So, on the basis of receiving the energy by the electron, when they are get heated, hydrogen atom, when the hydrogen is heated, the electrons are excited and they reaches to the higher energy state depending upon their heat received by them. When they comes to the lower energy state, they emits the radiations. The radiations consisting of particular wavelength, and we can get the series, and that series is called spectral series. We have got the 5 spectral series. Then what is their higher energy state? Then what is their lower energy state? When they jumps from higher energy state to the lower state, in which region of the electromagnetic spectrum they appears, all these factor counts. So, the spectral series consists of, now this is the spectral series. I make the chart to make the understanding easy. Then, this is nothing but energy state. दो है higher energy state N2, lower energy state N1. Then region of appearance in electromagnetic spectrum. We can make the simple hint LBP BP, low BP BP. LBP BP, low BP BP. L stands for Lyman series. यहाँ पे 2 है, हमको मालूम है बामर और ब्रैकेट. ABCD में ये फर्स्ट आता, R नेक्स्ट आता, बामर सीरीज, ये ब्रैकेट सीरीज. और 2 P है, एक फंड है और एक पैशन है. पैशन में PA फंड, PF पैशन सीरीज, फंड सीरीज, P फंड सीरीज. बाहर करने के सर लो BP BP. सो यहाँ पे N1 लिख दूं मैं, N2. So Lyman say 1, 2, 3, 4, 5. Jumping set is 1. Higher energy set कौन सा भी रहने दो, 1 के बाद 2, 3, 4 dash dash. 2 lower energy state, higher energy state 2 के बाद 3, 4, 5 dash dash. 3 lower energy state, higher energy state 3 के बाद कौन सा भी 4, 5, 6 dash dash 5 lower energy higher energy state 5, 6, 7 dash dash लोअर एनर्जी स्टेट 5 हायर एनर्जी स्टेट कौन सी भी ले लो उसके बाद 6, 7, 8 डैश डैश बात करने की जरूरत नहीं है वहाँ पे वहीं पे आप सेंटेंस बना सकते हैं नेक्स्ट राइट देन आफ्टर दिस in which region there appears in the electromagnetic spectrum that is the important factor first you take ultraviolet hint ultraviolet V stands for visible visible next hint infrared infrared तीनों infrared ultraviolet V is the next hint visible next hint I infrared infrared जब भी आते किसी को यहाँ पे एक आदमी ठहरे सो है आप उसके नज़दीक जाते नियर देन उसके पास इन उससे दूर नियर थोड़ा दूर लिख दो इससे नियर इन दिस इज फार खत्म दिस इज योर स्पेक्ट्रल सीरीज आप केमिस्ट्री में भी यूज कर सकते हैं इसे आप शायद फर्स्ट ईयर में पढ़े होंगे दिस इज अवर स्पेक्ट्रल सीरीज एक बार पूरा ग्लांस करो देन आई गो मेक द सेंटेंस इसी को लेके सेंटेंस बना दूंगा कोई बाहर सेंटेंस बाहर करने की जरूरत ही नहीं है आप लोगों को यहाँ पे पूरा रख लिए वी कैन मेक द सेंटेंस वी कैन राइट द इक्वेशंस राइट आप एनर्जी स्टेट लिख सकते इसके लिए nth ऑर्बिटल एनर्जी so that is nothing but वेव नंबर लिख सकते हैं वेव नंबर इसके लिए न्यू बार इज इक्वल्स टू आर 1 बाय n1 स्क्वायर माइनस n2 स्क्वायर n2 आप क्या भी ले सकते हैं यहाँ पे n1 1 है सो इसके लिए न्यू बार आर 1 बाय n1 स्क्वायर 2 स्क्वायर n2 स्क्वायर n2 आप कुछ भी लिख ले हाँ तो फिक्स है ना न्यू बार आर 1 बाय 3 स्क्वायर n2 स्क्वायर न्यू बार आर 1 बाय 4 स्क्वायर न्यू बार आर 5 स्क्वायर आप ये एक्स्ट्रा है लिखे तो लिख सकते हैं यहाँ पे इक्वेशन आप लोगों को इधर है What is that basic equation? Nu bar equals to R 1 by n1 square minus 1 by n2 square. अभी पढ़े सो इक्वेशन है राइट इसके लिए अगर नहीं होना है ले लो इधर लिखो कौन न को बोले आपका आप जैसा अंडरस्टैंडिंग कर लेते हैं उसके हिसाब से चले जाता चलो मैं बात नहीं कर सकता हूँ मत करो बात करो कौन बोल रहा है आप लोगों को राइट एक बार पूरा चार्ट को ग्लांस करो आई मेक द सेंटेंस देख लो पूरा right when the hydrogen gas is heated the electrons are get excited depending upon the thermal energy received by them they goes to the higher energy state when they returns back to the lower energy state they emits the energy in the form of spectral lines hence they gives the spectral series that spectral series for hydrogen atom we are given 5 that is 5 spectral series Lyman series Balmer series Paschen series bracket series and Pfund series when the electron jumps from any higher orbit to the first orbit we get Lyman series so higher orbit is 2 3 4 it appears in the region of electromagnetic spectrum ultraviolet region then its wave number is R 1 by n1 square is that is 1 square minus 1 by n2 square we can write n2 from which higher state it is coming if you know that n2 then you deciding the factor of what 2 3 4 when the electron jumps from any higher orbit to the second orbit we get Balmer series It appears in the visible region of the electromagnetic spectrum, and its wave number is r into bracket 1 by 2 square, that is 4, minus 1 by n2 square. When the electron jumps from any higher orbit to the third orbit, we get Paschen series, and it appears in the near infrared region of electromagnetic spectrum, and its wave number is r 1 by 3 square, that is 1 by 9 minus 1 by n2 square. When the electron jumps from any higher orbit to the fourth orbit, we get the bracket series. It appears in the region of what? Infrared region of electromagnetic spectrum. Nu bar equals to r 1 by 4 square minus 1 by n2 square. Then finally, when the electron jumps from any higher orbit to the fifth orbit, we get Fund series. It appears far infrared region of the electromagnetic spectrum, and its wave number nu bar equals to r 1 by 5 square 1 by 25 minus 1 by n2 square. Now this is our spectral series. एक बार पूरा अच्छी तरह से glance कर लो. Don't, there will be no need of biting the sentence, right? Is a देख लो आराम से. Then I come across the minimum and maximum wavelength of corresponding to spectral series. The minimum and maximum wavelength corresponds to spectral series. Next. निकाल दो इससे, right. Then I come across the minimum and maximum wavelength corresponds to spectral series. The minimum and maximum wavelength corresponds to spectral series. Right. The minimum and maximum wavelength, lambda minimum and lambda maximum corresponding to spectral series. When we get the maximum wavelength and minimum wavelength? When I come across the first one, lambda minimum. The lowest wavelength corresponding to the spectral series is known as lambda minimum. The lowest wavelength corresponding to the spectral series, corresponding spectral series is known as lambda minimum. This lambda minimum is obtained when the electron jumps to the any lower orbit from infinity. That is, when n2 equals to infinity, lambda minimum is obtained when n2 equals to infinity. When n2 equals to infinity. When the electron jumps from infinity to the any corresponding orbit, we get the minimum wavelength. Hence, 1 by lambda, we know that r 1 by n1 square minus 1 by n2 square. 1 by lambda minimum is equals to r 1 by n1 square minus 1 by infinity square. This is nothing but r by n1 square. 1 by infinity is 0 because 1 by infinity is 0. Right? So, 1 by lambda minimum is equals to r by n1 square. Then lambda minimum is equals to n1 square by r. If anyone is asked that in the NEET or CET, what is the minimum wavelength for Lyman series? For Lyman series, N1 equals to 1. So lambda minimum equals to 1 by R. For Balmer series, N1 equals to 2 square, 4 by R. Lambda minimum for Balmer series is 4 by R. For Fund series, N1 equals to 5, 25 by R. Now this is your minimum wavelength. Right? The lambda minimum is obtained when N2 equals to infinity. Then we cannot decide N1. जब वो N2 equals to infinity से जो ऑर्बिट को जंप करता, if you know that N1, then we can calculate whether it is Lyman series or Balmer series or Paschen series or Fund series. On that basis, N1 is going to be decided, but N2 should be confirmed. It is jumping from N2 equals to infinity. Then we get what? Minimum wavelength. Right? देख लो एक बार. Lambda minimum equals to N1 square by R. Then I come across lambda maximum equation को glance करो. Then lambda maximum को आ जाएंगे. Then I come across second one, lambda maximum. Maximum wavelength in any series can be obtained. Lambda maximum, the maximum value of the wavelength of any spectral series can be obtained. Lambda maximum can be obtained when N2 equals to N1 plus 1. रेसिप्रोकल में है. जब रेसिप्रोकल में वैल्यू कम हो जाता, ऑटोमेटिकली जब रेसिप्रोकल में वैल्यू जब बढ़ जाए, इसका इक्विवेलेंट वैल्यू क्या हो जाता, कम हो जाता. सो इसको N2 plus 1, that is N2 equals to N1 plus 1, we get the maximum wavelength. Then we know that 1 by lambda equals to R, 1 by N1 square minus 1 by N2 square. Lambda equals to lambda maximum when N2 equals to N1 plus 1. Therefore, 1 by lambda maximum is equals to R, 1 by N1 square minus 1 by N2 is nothing but N1 plus 1 whole square. This is your equation. Right? Now this is the maximum wavelength of corresponding spectral series. To have the minimum wavelength, what is the condition? N2 equals to infinity. To have the maximum wavelength condition, N2 equals to N1 plus 1. Now this is the maximum and minimum wavelength for corresponding spectral series. पूरे easy है, कोई दिक्कत नहीं है यहाँ पे. Right? एक बार equation check कर लो, then we go for the next thing. Right? So what are the things we have studied? Whatever the equations we have proved yesterday, that is nothing but the total energy of the electron in the stationary orbit, Enth equals to minus m z square e fourth divided by 8 epsilon naught square n square h square. इसके लिए हिंट दिए थे, nth ऑर्बिटल एनर्जी इक्वल्स टू माजी आत नाही, झूठ बोल रहे, माइनस साइन रख देते. राइट? By knowing that equation, we have calculated the nth orbital energy for hydrogen atom. So, nth orbital energy for hydrogen atom, Enth equals to minus 13.6 divided by n square electron volt. In generally, for any atom by considering the Z, so nth orbital energy equals to minus 13.6 divided by n square into Z square electron volt. Then we have calculated the individual energy for the hydrogen atom of respective orbits. Then after that, we come across the equation, that is wave number, by using the same equation of nth orbital energy. When the electron jumps from any higher orbit to the lower orbit, we receive the energy. That energy is in the form of photon E equals to h nu, then E equals to E2 minus E1, then En2 minus En1. By using that 10th orbital energy equation, we have brought the equation, that is wave number nu bar equals to reciprocal of wavelength 1 by lambda, that is 1 by lambda equals to r, where r is the Rydberg constant. That Rydberg constant r equals to m z square e4 divided by 8, so epsilon naught square ch cube. So where c is the velocity of the photon, that is 3 into 10 to the power 8 meter per second. By substituting all the constant values for hydrogen, it is estimated that theoretically and experimentally r equals to 1.097 into 10 to the power 7 per meter. Right? And after that, we come across the spectral series. When the hydrogen gas is heated, the electrons are excited. When they are excited, the excited depends on what? The amount of thermal energy received by the electrons. They goes to the higher energy state. When they returns to the lower energy state, they emits energy in the form of spectral lines. Hence, it gives the spectral series. The spectral series consists of 5 spectral series: Lyman series, Balmer series, Paschen series, bracket series and Fund series. Right? The region of appearance अगर सब दिए थे हम लोग, then after that we have calculated the maximum wavelength and minimum wavelength. The minimum wavelength is obtained when n2 equals to infinity. The maximum wavelength is obtained when n2 equals to n1 plus 1. Now these are the things we have studied today. The things left और एक theory class हो जाता, that is nothing but energy level diagram, excitation energy, ionization energy. Then we come across the merits and demerits of Bohr's atomic model. Then we come across what? The stationary orbit concept. उतना एक कल एक क्लास हो गया तो पूरा theory concept complete हो जाता. Then we come across numerical sections. Hope that you have understood. और कुछ भी डाउट रहे तो कमेंट बॉक्स में लिख सकते हैं और एक बार बोल के बोल सकते हैं. I hope that you have understood the things. Is it clear? Yes. Let me continue in the next class. Thank you.